Now we're going to have another example how to compute tides using again the Admiralty tide tables part 1. Now our problem here is to find the height of tide at 12 on 8 November at Standard Port. So we need to extract again the Admiralty tide tables in part 1 to fill up the tidal prediction form. So in number 1, 2, 3, 4 boxes, we're going to extract 823 as the high water. And in low water, it's 1440. So why do we get 823 and 1440? Because we need to find the height at 1200. 1200 is between 823 and 1440. So after we put the information in box number 1, box number 2, that is the high and low water times and height at Standard Port. Okay, extracted in part 1 of the Admiralty tide tables. Next thing we're going to do is to input the high water level. Beside 823 is 3.2 and beside 1440 is 1.4. Now to get the range, just simply subtract 1.4 to 3.2. It will give you 1.8. Okay, now for the duration, subtract 1440 or 823 into 1440. It will give you 6 hours duration and 17 minutes. Okay, but to get the height of the water in 1200, you need to interpolate because there is no exact value of 1200 in this Standard Port here. So to interpolate, to get the 1200 value, we need to get 823 and 1440 because it is in the middle. Okay, 1200 is in the middle of 823 and 1440. 823 is equivalent to 3.2, so put it here. 1200, that is the value that we need to get. 1440 is equivalent to 1.4. Now, to get the interpolation, 3.2 minus x is equals to x. 3.2 minus 1.4 is equals to 1.8. Now, 8 hours and 23 minutes. 12 hours minus 8 hours and 23 minutes. It will give you 3 hours and 3 hours or 3.6 hours. So 1440 or 14 hours and 40 minutes minus 8 hours and 23 minutes, it will give you 6.28 hours. Okay? So to demonstrate to you how to compute it using the calculator, so 1200, put it in degrees, minus 8, put it in degrees, 23, it will give you 3 hours and 37 minutes. Just press the degrees, it will give you 3.6. So there, 3.6 hours. Okay, now to get the value of x, cross multiply. X is over 1.8, x over 1.8, 3.6 over 6.8 or 28. So x is equals to 3.6 multiplied by 1.6 because you're going to cross multiply in order for x to be left So 3.6 multiplied by 1.8 divided by 6.28, it will give you 1.03. So this is not yet the value of our 1200. So to get that, you need to go back to subtract it in 3.2 to get the value of x. So 3.2 minus the value that we get, 1.03, it will give you 2.1. So therefore 1200 is equals to 2.1 meter. So the height of the water or the tide is 12 at 1200 is equals to 2.1. Okay, so there you have it.